Okay, let's dive right into this. Because if you've ever wondered how researchers actually prove something works, well, you stumbled upon one of the most fundamental choices they have to make. We're going to break down the two main ways to run an experiment. Do you use two completely different groups of people, or do you use the same group of people twice? It sounds super simple, right? But trust me, this one decision changes absolutely everything. So let's make this real for a second. Imagine you've created a new study app. It plays some special kind of music that you claim boosts concentration and helps students nail their exams. So, how do you prove it? I mean, really prove it. Do you grab two different classes, give one the app and the other total silence? Or do you take just one class and have them try it both ways? How you answer that question puts you at a huge fork in the road of how you design your research. And yep, those are our two core options. On one hand, we can compare two totally separate independent groups of people. And on the other hand, we can take the exact same group of people and measure them twice, creating what we call a related or dependent set of data. Let's explore that first path, the two different groups. So this first approach is often called the independent groups design. The key idea here, the most important thing to remember, is that every single person in the study only experiences one version of our experiment. They are completely separate from each other. Here's the more official, kind of textbook definition. When you have independent samples, it just means your data comes from two or more different groups. A person in Group A has absolutely no connection to a person in Group B. They are, in a word, independent. Let's go back to our study app. Using this design, we'd randomly split a bunch of students into two groups. Group 1, they take their exam while listening to our amazing app. Group 2 takes the exact same exam, but in complete silence. And after that, all we do is compare the average test scores between the two groups and see if the app actually made a difference. Simple enough? Now, the biggest plus for doing it this way is that you totally avoid something called order effects. Think about it. Since each person only takes the test once, they can't get better just from practice. And they also can't get tired or bored and do worse. Their performance is just a clean, one-time snapshot. But, and this is a big but, here's the trade-off. What if just by pure random chance, Group 1, the app group, ended up with students who were just smarter or more motivated? These individual differences between people can really muddy the waters, making it hard to know for sure if a better score was because of your app or just because you accidentally got the more studious group. So how in the world do we solve that problem of individual differences? Well, that brings us to our second path. This one is known as a repeated measures or dependent samples design. And as you're about to see, it perfectly fixes our first issue. But yeah, it creates a whole new one. So in a dependent sample, all the measurements are related to each other. Most of the time, this just means testing the same exact people at two different times, like a classic before and after test, but it can also apply to pairs that are naturally linked, like comparing husbands to their own wives or one identical twin to the other. The key is the data points don't stand alone. They always come in a pair. Let's look at our study app again, but with this new design. We'd have just one group of students. First, every single one of them takes a baseline test in silence. That's our pre-test. Then, they all use the app and take a second, similar test. Now here's the magic. We aren't comparing Group A to Group B anymore. We are comparing each student's score to their own personal baseline score. And that, right there, is the superpower of this design. It completely eliminates those pesky participant variables. It doesn't matter if one student is a genius and another struggles. Who cares? You are measuring the change within each person. This gives the design way more statistical power, and you can often get away with using fewer people. But remember that order effects problem we solved earlier? Well, it's back. Now we have to worry about it. Did the students do better the second time just because they'd already practiced the test format? Or maybe they got tired and did worse. These kinds of effects can now totally mess with our results. Thankfully, researchers came up with a pretty clever fix for this, called counterbalancing. To cancel out any practice or fatigue effects, they just split the group in half. Half the group does silence first, then the app, and the other half does app first, then silence. By mixing up the order, those order effects should hopefully wash out and not bias the final results. All right, time for a little quiz. Let's look at this research idea. A study wants to find out if husbands get more sleep than wives. Now, on the surface, that sounds pretty simple, but how you set this experiment up is absolutely everything. So, what do you think? Based on what we've just talked about, would you use an independent or a dependent design to test this? The answer, well, it's not quite as obvious as it might seem. And the answer is, it totally depends on how you set it up. If your data is made of married couples and you are specifically pairing each husband's sleep hours with his own wife's sleep hours, that is a dependent design. The data is paired. But if you just go out and survey a random group of men who are husbands and a completely separate random group of women who are wives, well, now you have two independent samples. The wording sounds almost identical, but the way you'd have to analyze the data is completely different. Okay, let's put this all together. We've seen the good and the bad of each approach. So let's just look at them side by side. This should make the trade-offs really, really clear. What's so great about this is that it's basically the decision-making cheat sheet for any researcher. You see, if you can get lots of participants and you're really worried about order effects, you go independent. But if you have fewer people available and controlling for those individual differences is your absolute top priority, then you go with a repeated or dependent design. Now, you might be thinking, okay, this is a bit technical, a bit nerdy, but this single choice, made right at the very beginning of a study, has massive consequences for the entire rest of the project. This is not just some academic detail. Seriously, this one decision has a huge domino effect. It determines how powerful your study is, which tells you how many people you even need to recruit. It impacts the fundamental validity of what you can conclude, and as we're about to see, it locks you into a very specific mathematical tool. If you get this choice wrong at the start, your whole study could be junk. And this slide illustrates the point perfectly. This distinction between dependent and independent samples isn't just a concept. It's a practical rule that literally tells you which statistical tool you have to use. If your samples are dependent, you have to use a test for paired data, like a paired samples t-test. If they're independent, you have no choice but to use its counterpart, the independent samples t-test. You can't mix and match. So, the crucial point, the main takeaway from all of this is that deciding between an independent and a dependent design is like choosing the blueprint for a house before you even pour the foundation. It is the first, most critical decision that shapes the structure of everything that comes after. So let's end with one last little thought experiment for you. Imagine you work for a pet food company. You've got a new cat food, we'll call it Yum, and you want to prove it's way more appealing than the old stuff, Nobles. So what would you do? Would you get two different groups of cats and give each group only one type of food? Or would you get one group of cats and let them try both foods, maybe on different days? Think about it. The pros, the cons, the success of your new cat food might just depend on that choice.